Okay, the lighting's not the best here. Just wanted to give another mention of this excellent book, um, Negative Mass by Martinez. So I ordered it through the mail. Oh, no, actually, I think it's, yeah, thrift books. How math rules can be positively bent. And it's, good morning. It's a really fascinating analysis of logical problems in mathematics. And a little shout out to Terrence Howard because he's been made fun of a lot for making claims about, I don't know, I don't even know what his claims are, to be honest, but something about one one times one is greater than two or something like that. I don't know, or is two and not one. And anyway, this book gets into those same kind of problems, and it has to do with the imaginary number, how the square root of -1 is defined. Because when you take square roots, you get negative and positive results. And so obviously this topic can get really dry really fast, but the thing is that you start to realize that it challenges basic scientific truths, but it does so through rational analysis of mathematics. So when you just start studying math like in detail, he's talking about Euler and he's saying, oh, Euler made these discoveries, and then the other mathematicians tried to cover it up. And the same happened with Maxwell. And so the simplification of Maxwell was by Heaviside and Gibbs, who argued that vector math is more appropriate for physical reality versus the quaternions that Maxwell was using, because you get into non-commutative mathematics with using the imaginary number. So it's just like basic logical errors in mathematics. And yeah, I don't want to go into all the into any I don't want to go into all the into any real details, but once you finally get to you're going through the book and you get about halfway through the book, which I am right now, and he says asymmetries yield complications which can admit ambiguities, which sometimes entails mistakes. And that sentence right there really sums it up, because you start to learn that in terms of non-locality, the mathematics is a process. Excuse me, a process. So the asymmetries are showing up whenever you take an external measurement, or what they call an observation, as the rest frame in relativity. You actually get an asymmetry because it takes time to make a measurement. And so in terms of the mathematics, whenever something takes time, it actually is an iteration of the math, and that changes the value. And so this has to do with the square roots of -1 in terms of that being a time shift operator. And this has really been the focus of math professor Lewis Kaufman. But it's also been the focus of Alon Khan. And essentially, the idea is that, like, if you think of relativity, they talk about the difference between a hyperbole for infinity versus a circle And so when you have that hyperbole, you get the speed of the speed of light as the invariance, because it's a ratio between the time and the space as a hyperbole. But when you realize when you're dealing with the square root of -1 in terms of time, you end up getting this fifth dimension, because you have a 720 degrees spin. So you have a inherent 1/2 spin to the light, and that changes the speed of light. So you get this superluminal phase. And that's what is based on the asymmetry in the mathematics. So, what this book is dealing with is just the mathematics directly without the physics. And so I times A no longer equals A times I when you are including J and K in terms of the quaternions. So you have an asymmetry in the value based on the time shift. And what Alon Khan does is he points out this is what is the truth of music also when you consider pitch. So you have the perfect fifth is the same pitch, but it's a different frequency, whether it's an undertone or overtone. So you have that ratio of 2/3 or 3/2, and it changes the geometry. So normally you'd have a one-to-one value of number and geometry, but in music, you have the two is like the root tonic of C, so it's an octave, so C is one, but then the three is both F and G at the same time. So in relativity, they're basically saying simultaneity no longer exists because of that speed of light invariance. But in non-locality, you actually still have simultaneity and you have action at a distance. And they just call it a correlation because technically you can't send information as information is traditionally defined based on amplitude. But in terms of the mathematics, you can still have information that is what Basil J. Halley calls it active information, or it's also called the quantum potential. So it's just like pure phase before amplitude exists. So that would be your time and frequency that are inverse to each other. So you can have this negative frequency as virtual photons, and yeah, so it's completely changed how you define energy because then you violate the invariance principle of physics and you have violation of the conservation of momentum because you're defining energy from as mass from the momentum of the photon. And this is basically what they're getting into in that article, Light is Heavy, by Gerard de Hooft and Martin van der Mark. So it really challenges relativity on a fundamental level, and we know that in Bell's inequality that Einstein was disproven. But you just don't find that in science. Like the physics, everybody just adheres to relativity because that's the mathematics that they learn. And since mathematics is the language of science, everybody's just relying on all this mathematics that they learned, and they can't change the mathematics because that's like the language that they speak. It's like the water that they're swimming in, so they can't change the water. So that's essentially why you get the physics wrong because you have the mathematics wrong. So that's really what this book commutativity in here. Oops, I'm losing the connection. So